Hi, we're back again, and hopefully these recordings are helping you, and that everything's going well with it on my end, because I'm not really sure sometimes whether the audio or the video is coming out until I'm actually done. So, and then of course when you post them on YouTube, sometimes there's a little bit of technical problems. So hopefully this is working out and it's helping you. Last time we were talking about impulse, and we said that impulse was a change in momentum. So when we have the object's momentum change, meaning it changes its velocity, basically, some force has to be applied in order to make that happen. Things don't, on their own, speed up or slow down unless something pushes them or tends to pull them. Some force, in other words, has to push something to make it go faster, or some force has to push against it or pull against it to make it go slower. It reminds me of a small child on a swing, and the adult is behind the child, and the child wants to go faster. In order to get the kid going faster, you have to apply a force. Your hands are on the child for a particular couple of seconds, and that force times the time will result in the kid going faster on the swing. So he changed. What happens is the force of your hands pushing changes the momentum of the child on the swing. Let's look at it from a different angle and have a little bit of fun here with an egg. We're going to drop an egg. So this is an egg, and to make it fun, we're going to say that this guy here is not a hard-boiled egg. It's just a regular egg. So when it hits the ground, you know what's going to happen. It's going to crack because the force is very great. So our egg is up in the air, and let's just say we've got the ground over here. Now we're going to release this egg. By the way, you remember this egg's got some potential energy. So just to recall, to refresh your memories, it's got gravitational potential energy equal to mgh, which is the mass times g times the height. So this gravitational potential energy, it starts from rest up here. It's a height h off the ground, h meters off the ground. It's got some mass. It's got some potential energy. And the moral of the story is that when this guy finally gets to this position right here, just as it just starts to touch the ground, it's got all of the potential energy here gets converted into kinetic energy, and over here it's got kinetic energy equal to 1/2 the mass of the egg times its final velocity squared, which is a velocity just as it's going to hit the ground. All right? So here, its velocity is 0. So its initial momentum equals mass times its initial velocity is going to be 0 as well. Here we've got a momentum. Just as it starts to hit the ground, its momentum here is going to be the mass times its velocity here. And instead of calling it final velocity, I'm just going to call it velocity in yellow. And there's a reason I'm going to do it. Just let's say it's yellow. That's its velocity just as it's going to hit the ground. Mass times that velocity is its momentum just as it's hitting the ground. So this guy here, just as it hits, it's got some velocity v. And let's not put numbers in it just yet. If we wanted to blow up this picture of this egg just microseconds before it makes contact over here, we've got some velocity v, and then it hits, and when it hits, so this is over here, now all of a sudden it hits, and now it makes contact, boom, all of a sudden it's not moving anymore, so its velocity here is 0. So we go from a final from initial velocity here just a hair before it hits the floor, and now all of a sudden it hits the floor, its velocity has to be 0 because it stops as soon as it hits the floor. And that happens very, very, very quickly. So the time that that happens, delta t, is very small. This egg changes its momentum very, very quickly, because right over here, the momentum is the mass. This egg has a mass. It's the same egg just as it's hitting here, times v. This momentum here is mass times 0, because now the egg is stopped. The floor stops the egg from going any faster. But that change in velocity occurs very, very, very quickly. So the time interval for the change, for go from one velocity to 0, is very, very small. So there's our change in momentum. Change in momentum is equal to the force times the time is equal to mv, delta mv, let's say, change in momentum. This momentum change is going to simply be the mass of the egg times the final velocity, which is 0, minus the initial velocity, which is v. All right? So in magnitude, well, it's just negative mv, which means you have to apply a force times a time interval to equal, at least in magnitude, mass times the mass times the velocity. Hope I'm not confusing you. We're going to go over this again. So this force then, you see, has to be large if this guy is small. If the time interval here, delta t, becomes very, very small, then the force has to become very large in order to equal this change in momentum. So let me just pause at this point, and well, let's see, we don't have to pause. Let's go up here and see if we can put some real numbers into this. So here we have our egg, and let's say the egg is it's a huge egg, maybe it's an ostrich egg. Let's say it's 1 kilogram, just so we have even numbers here. And the velocity just before it hits the ground, v, is equal to, let's just say 5 meters per second. Okay, that's its velocity just before. Now the egg hits the ground and its velocity is 0 meters per second because it just hit. So let me ask you the question, what is going to be the change in momentum? The change in momentum is the final velocity times mass, which is m times 0. M is 1 kilogram, right? That's what we said. It was a huge egg. So it's 1 kilogram times 0 minus 1 kilogram times 5. And let's say up is the plus direction. So this velocity is -5, and which results in a change of momentum of 5 kilogram meter per second. There's my change in momentum. Let's say this happens, delta t, from the time it's just above the floor surface till the time that the floor makes contact with it. This changes in 0.001 seconds. So it's very, very, very fast. It's a millisecond. So let's calculate the force then that has to be applied. So force times time is equal to the change in momentum. Force times 0.001 has to equal this change in momentum, which we said was 5. So our force is going to be 5 divided by 0.001, which is going to be 5,000 newtons. And this is the force. This force F is a force that's being applied upward against the egg from the floor. The floor is actually exerting the force on the egg to change its momentum. In other words, to stop it. So that's 5,000 newtons. Now I'm going to just stop it here, and in the next video we're going to see what happens if we put a pillow on the floor and we drop the same egg.